type of variable. Take a look. Each value of a discrete random variable can be assigned a probability. By listing each value of the random variable with its corresponding probability, you are forming a discrete probability distribution. To construct a discrete probability distribution, suppose X is a discrete random variable. Possible outcomes are X sub 1, X sub 2, X sub 3, X sub n. Then you're going to make a frequency distribution for the possible outcomes. You can find the sum of all frequencies. You can find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. So it should ring a bell because you learned about relative frequency in previous chapter. So the probability is basically finding the relative frequency for a discrete random variable. So again, pay attention here. Probability distribution for a discrete random variable is basically the same as relative frequency. For relative frequency, you had a class frequency divided by the sample size, or f divided by n. Now, for each x value in a discrete random variable, you have some frequencies, and then you're going to take that frequency and divide it by the sum of all frequencies. Let's take a look at one example to feel more comfortable about these steps. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown at the left. I moved the table to the right so we have enough space we can write. So take a look at your table here. So again, a psychologist ran this survey. You have 150 employees. 24 employees scored 1. 33 employees scored 2. 42 employees scored 3. 30 employees scored 4. 21 employees scored 5. So again, think about a large class with 150 students, and then you run this survey for your class. 24 students answered the question and they got score 1. Out of 150 students, 33 of them got score 2. Out of 150 students, 42 got score 3. Out of 150 students, 30 got score 4. You can think about it as a test. Out of 150 students, 21 of them got score 5. Now we are interested in forming the probability for each random value. So please note that x is a discrete random variable because you can list x values right here. X can be 1, x can be 2, x can be 3, x can be 4, and x can be 5. So this is the definition of this survey. X is a discrete random variable. Now, how do we calculate the probability distribution? Divide the frequency of each score by the total number of individuals in the study. How many people? 150 people. If you add all of these numbers together, it adds up to 150. 24 plus 33 plus 42 plus 30 plus 21 is 150. So let us begin. probability of score 1 is the frequency of score 1, which is 24, and you're going to divide that by total frequencies, or the total number of people who participated in the study. If you do the division, it's equal to 0.16. It means that 16% of 150 employees got score 1. So remember that when we talked about relative frequency shows the amount relative to the rest of the entries or outcomes or data in your collection. So the probability of score 1 is 16%. What's the meaning of that? It means that if I randomly select a score, it's 16% associated to 1. Or if I randomly select one of these people, the probability that they got score 1 is 16%. So now that you have your frequency, you can basically associate these to the frequency that you have. Let us move on to the second probability. The probability of score 2 is 33, which is the frequency of score 2 divided by 150, which is basically total number of people in the study. You get 22%. It makes sense. The denominators are the same, but the numerator is increasing. So we expect to get a higher percentage. So again, what's the meaning of that? It means that if I randomly select one of these people, the probability that that person have scored 2 is 22%. Let's move on to the next probability. Probability of score 3 is 42, which is the frequency of score 3, divided by 50, 150, which is the total number of employees or people participated in the study. If you do the division, get 0.28 or 28%. And again, compare these numbers. The denominators are all the same, but the numerators are increasing. So we expect to see higher percentage. So if I take a random employee and want to know what is the probability of 3, that is going to be 28%. Next probability is for score 4, which is 30 divided by 150 or 20%. Probability of 5 is 21 over 150 or 14%. So these are the probabilities for each one of these scores. If you add these together, add these probabilities together, it adds to 100% or 1. The question also says, hey, graph this, use a histogram. Okay, let us begin. For a histogram, we need a horizontal line, which indicates x values, starting from 1 to 2, then 3, 4, 5, are all listed on x-axis. On the vertical line, since the highest probability is 28%, I'm not going to go more than 30%. I'm going to scale it to 30%. So again, look for the highest probability in your calculation. The closest number to 28% is 30% or 0.30. I'm not going to go more than 30%. Now, the probability for 1 is 16%. So 1 has probability 16%. The bar that represents the frequency, or in this case, the relative frequency or the probability, note that we are using P of X, is equal to 16% or 0.16. That's why the bar stops at 16%. The probability for 2, as you can see, is 22%. So this bar is going to stay around 22% or 0.22. We can match this height to 22%. For 3, the probability is 28%. So we look at 3. 3 is the representative for this bar. The bar has height near 28%. So this is the third bar. The fourth bar is going to stop at 20%. 4 is the representative for the score here with probability 20%. And finally, the last one is for 5. The probability for 5 is 14%. And as you can see, the height of the graph match here.